Hey everyone, and welcome back to the channel. Today, we're diving into a super cool piece of cryptographic magic called a verifiable delay function, or VDF. Now, that might sound a bit complex, but stick with me, because VDFs are solving some really fascinating problems in the digital world, especially when it comes to fairness and randomness. Imagine you're trying to generate a random number, like for a lottery or a game. How do you prove that you didn't just pick the number that benefits you? Or what if you need to prove a certain amount of time has actually passed? On a computer, you can't just trust the clock. That's where VDFs come in. Think of a VDF as a special kind of puzzle. It's designed to take a specific, predictable amount of time to solve, even for the fastest supercomputers in the world. You can't cheat and solve it faster by throwing more processing power at it. The only way to solve it is to go through each and every step, one after the other. It's like a time-release safe that you can't break into early, no matter how hard you try. So, let's break it down. A VDF has three main parts. First, there's the setup, where you define the puzzle and how long it should take to solve. Second, there's the evaluation. This is the actual solving part, the step-by-step computation that forces a delay. If you set the delay to, say, 10 minutes, it will take at least 10 minutes of continuous computation to get the answer. There are no shortcuts. And here's the magic, the third part, verification. Once the puzzle is solved and you have the result, anyone can check that it's the correct answer almost instantly. They don't have to spend 10 minutes doing all the work. They can just look at the solution and the original puzzle and say, yep, that's correct, and I know it must have taken you at least 10 minutes to produce this. This is the verifiable part of verifiable delay function. So, where is this useful? One of the biggest applications is in generating public randomness, especially for blockchain networks. Think of a public lottery run on a blockchain. You need a way to generate a winning number that is truly random and can't be influenced by anyone. With a VDF, you can take a piece of recent data from the blockchain, run it through a VDF, and the output becomes your random number. Because of the built-in time delay, no one can predict or manipulate the outcome. It ensures a fair and tamper-proof result. This is also huge for something called leader election in certain blockchain systems. Instead of having powerful miners compete with brute force, a VDF can create a sort of lottery to decide who gets to produce the next block. It levels the playing field and makes the network more secure and decentralized. Beyond blockchain, VDFs have potential in things like sealed bid auctions, where you want to ensure all bids are revealed at the same time, or even in creating proof of time for digital documents. It's a fundamental building block for creating trust in digital systems without relying on a central authority. In a world where digital manipulation is a growing concern, tools like VDFs are incredibly powerful. They give us a way to mathematically enforce the passage of time, ensuring fairness and unpredictability in a way that was previously very difficult. It is a brilliant blend of math and computer science that is making our digital future more secure and trustworthy. So, the next time you hear about a system needing fair, unpredictable randomness, you'll know the secret ingredient might just be a verifiable delay function quietly ticking away to keep things honest. Thanks so much for watching. If you found this interesting and want to learn more about cool tech concepts, be sure to hit that like button and subscribe to the channel. It really helps us out. Drop any questions you have in the comments below, and we'll see you in the next video.